Hi, thanks for joining me. Today I've got a number theory problem I want to share with you. We have primes p and q. We want to know, is it possible for p minus q and p plus q to both be prime? Okay, so are there primes p and q such that p minus q is prime and p plus q is prime? If you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so we have that p and q are primes, and we want to see if it's possible for p minus q and p plus q to be prime. Well, certainly prime numbers are positive, so that tells me that p minus q must be positive, and in particular p is bigger than q. Okay, now if p and q were both odd, then that would mean that p plus q would be also even, because an odd plus an odd is even. But remember, p and q are primes, so that means that if they're odd, they're both at least 3, so then that means that p plus q is at least 6, but any even number which is at least 6 is certainly not prime. So that means that both p and q can't both be odd, so one of them must be even, but the only even prime number is 2, so that tells me that at least one of them is 2, and in fact they both can't be 2, because that would contradict this guy here. So that means that one of them's 2 and the other one is odd. And again, because 2 is the smallest prime, that tells me that q must be 2. So I have that q equals 2 and p is some odd prime bigger than 2. Okay, well now we have p minus q is just p minus 2. P is just p. And p plus q is p plus 2. And we have that all of these, or we want all of these here to be prime. Okay, now what I'm going to do is just look at this guy mod 3. So the remainder of each of these numbers here, when I divide by 3, so this thing here is nothing but p plus 1 mod 3. And that's because, well, p is the same as p, and minus 2 is the same as plus 1 mod 3. This guy here is just p, and this guy here is p minus 1 mod 3, because 2 is the same as minus 1 mod 3. So each of these terms here are different mod 3. They're different integers mod 3, which tells me exactly one of these terms here is 0 mod 3. Okay, so exactly one of these things is 0 mod 3. We don't know which one, but that tells us that one of them is a multiple of 3. So if we track back up, one of these terms here is a multiple of 3. So the only way we can avoid it being prime is if the term that's divisible by 3 is exactly 3, because 3 is the only multiple of 3 which is prime. Okay, so we require either p minus 2 to be 3, p to be 3, or p plus 2 to be 3. But if we have p plus 2 being 3, let's rub this off. If p plus 2 was 3, well then that implies that p equals 1, but that contradicts this guy here because 1 is not bigger than 2. Okay, if p was 3, then we have 3 minus 2, which is p minus q. 3 minus 2 is 1, and 1 is not prime. So then this would imply that p minus q, which is equal to 3 minus 2 equals 1, but that's not prime. So then the only option is then for p minus 2 to be 3. So p minus 2 equals 3, and that implies that p equals 5. Okay, so now let's just check. So we've shown that these cases don't work. Let's just check that this one does work. Well, p is 5. Well, that's great because 5 is a prime. Q is 2, that's a prime. P minus q is 5 minus 2, which is 3, which is a prime. And then p plus q is 5 plus 2, which is 7, which is a prime. So that tells me that this is the only solution. P, Q equals 5, 2. Like so. And I guess, that's the only solution to this problem. P being 5 and Q being equal to 2. A nice short number theory problem for you. I hope you have enjoyed this quick video solution. Thanks for watching. I'll catch you in the next one. Have a great day.